Hello. Now we are going to go through some extra examples of the order in which we do our sums. And throughout, what we're looking for is to count up the total number of units. And to do that, we need to figure out how to describe each one of our terms in units and then count up the total number of units. So if we start with this sum here, we have 9 minus 4 plus 10. So what that means is we have 9 of a particular unit minus 4 of the same unit plus 10 of the same unit. So it could be euro. If we had 9 euro and we took away or gave away 4 euro and then got another 10 euro, how many euro would we have in total? Well, then euro would be our unit. It's what we're counting up. So because we're counting up the same thing in each of those three terms, we can just start to add and subtract to find out our total number of units. So I have 9 units minus 4 units is going to leave me with 5 units. And I still have that 10 units going on there. So I can see that I have 9 minus 4 is 5. I can see where that 5 has come from. And 10 hasn't done anything, so it just gets written down beneath. That's the structure I need to use for my sums. Now I have 5 units plus 10 units is a total of 15 units. If we go on to our second example here, we have 8 minus 16 all over 2 plus 3 to the power of 2, which is sometimes called 3 squared. So we have lots of stuff going on here. We have division. Fractions are the same as division. So this 16 all over 2, we could write as 16 divided by 2. That's another way that that could be written. And we're saying how many 2's go into 16, or what is the highest common factor of those two numbers. And then 3 to the power of 2 means how many times am I going to multiply 3 by itself? I'm going to multiply it by itself 2 times. So 3 to the power of 2 means multiply 3 by itself 2 times. Our power tells us how many times we multiply our base number by itself. So with that, we now need to start turning stuff into units, because this is something squared, this is a fraction all over 2, this is counting in ones. So this is not what we want. We need to start converting all of these terms to units. So each of these are terms. Can we call them by, or can we say how many units they represent? The 8 is straightforward. It's already 8 units. And then we're taking away how many 2's are there in 16? There are 8 of them. And then 3 to the power of 2 means 3 times 3. And we use brackets to show multiplication. So now we have converted our middle term to units. We still have some work to do here. We have 3 groups of 3. So in total we'd have 9. So we'd have 8 minus 8 plus 9. The fact that we had 8 units here minus 8 units here, it would be perfectly fine to do this sum and see that we get 0 units overall from this part of the sum. It would be okay to do that. As a general rule, when we're getting used to doing these sums, it's better to write everything as units before we start to do add or subtract. It makes it less likely that we make mistakes. So I've converted everything to units now. Now I'm going to start counting up my total number of units. So if I add together my first two numbers on the left, I have 8 minus 8. Well, if I have 8 of something and I give 8 of it away, I'm left with none of it. So that would be equal to 0 plus 9, which is just 9. If we add 0 onto something, it's unchanged. Now here we have 7 minus 3 times 2. So this means we have 7 units minus 3 groups of 2. So if we wrote this out the really long way, we'd have 7 minus 2 minus 2 minus 2. We're taking away 3 groups of 2. What it doesn't mean is the same thing as 4 times 2. So if we said we had 7 minus 3 is going to leave us with 4 by 2 is 8, that would be complete nonsense, because that's not what the sentence means. So we have to be careful when we're doing our sums and take a minute and read what they mean. 7 by itself means 7 groups of 1, 7 units. And we're taking away 3 groups of 2 units. And if we read it in that way, we never make mistakes. And we have to take our time now practicing this language and making sure we can read it like we could read any other language. So we have 7 groups of 1 taking away 3 groups of 2. So that would mean we'd have 7 units. And if we're taking away 3 groups of 2, that's the same as taking away 6 units in total. 3 by 2 is 6, and we're taking all of that away. And then 7 minus 6 is going to leave us with 1 unit overall. Here we have 21 divided by 10 minus 3. So it's difficult for us to figure out how many 10 minus 3s go into 21, which is what our fraction symbol here means. How many of these, how many of all of this goes into 21? That's a little bit complicated to think about. So what we should do when we get fractions like this that have complicated stuff top and bottom is try and write the number of units on top and the number of units on the bottom and see how many of these would fit into this, or what would be our highest common factor. So 10 minus 3, if we have 10 units minus 3 units, that's just going to be 7 units. So we end up with, we usually write this underneath, so as I have space I will as well, 21 all over 7 units. So now we're asking the question, how many 7s fit into 21, or what is the highest common factor of 7 and 21? Is going to be 7, and we're left with 3. So we have 3 groups. We break up our 21 into 3 groups, so we would just be left with 3 units as our final answer. Here we have the tick symbol here over the 36 means the square root. There's no number written inside the tick here, which would tell us if it was a different kind of root. So the standard kind of root is square root, and that tells us how many or what number would we multiply by itself 2 times in order to end up with 36. And that's all divided by 2. And then we have plus 14 units. So I can't add these things together at the moment. This is underneath a square root, and I'm counting in halves. I'm dividing by 2 in this term. This is counting in units. So I need to compare like with like. So to do that, I am going to see if I can simplify the top and the bottom of the fraction. So I have, what number would I multiply by itself to give 36? That would be 6. So I have 6 divided by 2 plus 14. Again, I can see line by line. The only thing I changed was that I said I know that the square root of 36 is going to be 6, because 6 times 6 is 36. Now, how many 2's fit into 6? Or if I take out my highest common factor, what would this number become? There would be 3 2's in 6. So I'm left with 3 plus 14. And now both of these are just units. I can count up my total number of units, and I have 17 units overall. Here I have 6 plus 2 brackets, 12 minus 5. So what does that mean? I have 6 units, and I want to add on 2 of these here. Now, what that means is I have this added to itself 2 times. So I can write it that way, or I can say, well, this is a fairly big sum to have to write out twice. So I could say, what is 12 minus 5? And that would simplify my work. It would make it easier for me to do the next step. Saying 2 times this big mess here, 2 of all of this, is a little bit complicated. So we can simplify this first in order to see our sums more easily. So we would end up with 6 plus 2 groups of 12 minus 5 is going to give us 12 minus 5 is going to give us 7. And now it's a little bit easier. So we did the stuff that was in brackets first because it makes it easier to now see what 2 of this group is going to look like. So now we can say 6 units. Again, the 6 hasn't done anything yet, so we just keep it in place so that we don't lose track of it. And then we have 2 groups of 7 units, so we'd have a total of 14 units. And then we have 6 plus 14 is going to be 20 units in total. So those are some extra examples of how we figure out the order of operations, the order we do our sums in. And all the time we're trying to figure out how many units we've got so that we can then compare like with like. We can count up the total number of units that we're talking about. And that is what we need for now.